I would like to go deeper to the technology, what is not easy because we developed this technology for a long time, and in 10 minutes we cannot mention all details and all features. But anyway, I will try to explain. I will start with the smartCylinder 2.0. It's probably, if we will speak in timeline, you will be a little bit surprised why we started with smartCylinder 2.0. But to be honest, the beginning was the cartridge amplifier, where we will come later. But I would say this was the case when it was the fully Siginolfi, or I would say under the Siginolfi development, this project, the smartCylinder 2.0. Before the smartCylinder 2.0 technology, we had the experience with the cartridge amplifier technology, but we wanted to make something, I would say, more powerful, more with a better performance, more easy for integration. So at first, the base of this technology is the oscillating double-acting boosting principle. This is, I would say, nothing new, the double-acting boosters existing on the market. But what is the new? In this case, it is this integration. The integration is consisting of the piston plugs and special H piston, like you can see here. And all these things, all this double-acting boosting principle is, I would say, effective and unique way how to make it in our design. And of course, it is integrated in a rod eye of the hydraulic cylinder or in a cylinder tube, the plate cylinder, like Sergio mentioned a few seconds before me. What is another thing? Here you can see that in the rod eye we have normally, it means that we have more options, and it's a little bit like I don't know how to say, maybe the Lego. You have the components and you can distribute the components over the cylinder like you want. When you need this component here because you have the space there and customer like it, you can put it there. If you need it to put it to the rod, you can do that. That's fine. This is a big advantage of this technology, but it's also one disadvantage, which I will come a little bit later to this. So we have some special sequence valve and all these things. Really, I would say just very shortly to explain how it is working. You have this H piston, and this H piston is oscillating to the left and right. And during this movement, on one side you are compressing the volume and boosting the pressure. It's in a very simple way. You need some additional, I don't know, the control valve, some check valves, and so on. But really, I think there is no time to go deeply in this way. What is also unique for smartCylinder 2.0 is that we are using the flow control element, I would say, undeveloped. Of course, we can use some components which are on the market, but to be honest, they are not the components which are, I would say, following our needs. And due to this, we have to go, or we developed the own solution for the flow control element. Again, it is an option. You can still have the one which you can find on the market, and it has some limitation from, I would say, flow point of view. But there was very difficult to find a flow control valve, or in this case, counterbalance valve or over-center valve. We don't need to go in the details, which is over the 200 liters. So due to this, we developed two versions. It is a 500-liter version of this valve and 1,000 liters version, which is resisting 700 bar. I think this is really, I am sure that this is something unique on the market. And I think this is I would say, consequence of the smartCylinder technology development, because there is a lot of, this example is very nice also, where we can see great cooperation between the Siginolfi engineering team, Smart Fluid Power, and also the external company Elt Fluid team, which is the expert for the valve. So we connect all together and we cooperate to develop this unique solution suitable for actually demolition market. For the future, we will see. So we have this smartCylinder 2.0, but in the end, we say, okay, What about the smartCylinder 1.0? It was this, I would say, original idea of the cartridge amplifier of one cartridge which you can insert to the rod of the cylinder, and you have a very good, I would say, the solution. Of course, it has some disadvantages. As I mentioned, it is quite compact, but of course, the fluid is not compressible and flow capability is limited. On the other hand, it is helping to design the cylinder easily. So you don't need to spend more time on designing of the cylinder components, distributing, but your cylinder design can be easily, I would say, done, and also from cost point of view, it is good. But of course, you pay for this advantage of easy integration. You pay with the performance, but that's fine. For some application, we are really okay with that. This technology is also based on the smartCylinder 2.0 because it was working, we were happy, so we say, okay, if we need to build the cartridge, we will do it in similar way. So we built the C piston type and the piston plug and again the oscillating. In this case, it is only the single acting. It means that during the one movement of the piston, you are delivering the fluid, and then the second movement of the piston when you are retracting is not used. So this is the cost which we need to pay for this technology, but I think it was a really good step because we also, for example, we decreased the diameter of this cartridge from 100 millimeters to 80 millimeters. What is really too much, according to me. And there is also the improved boosting and bypass capability because we increase some bypass channels and so on. And another advantage is that we have some sections, so we can build the cartridge according our needs in terms of the flow. Here you can see the animation of how smartCylinder 1 is working. And you see all these components, how they are moving, ticking, and boosting the pressure. So this is the one point. And okay, I know that for now for you was a little bit confusing. smartCylinder 2, smartCylinder 1, and so on and so on. Due to this, I make this table, which is showing you what we mean by the smartCylinder 1. The smartCylinder 1 is the cartridge technology where the booster is in the cartridge and normally is in the rod. There is no other option. For the smartCylinder 2.0, we have this oscillating double acting principle, which is normally in a rod eye or in the tube. And we have some various amplification options. And so generally, you see that we are trying to cover all flows from 50 liters to 1,000 liters in bypass and some other details. So that's the point. How we did it. There was a lot of work about it. I would say that one of the key points here is the clear cooperation between the customer, sales, engineering, and production. Through the whole development, we use the digital twin approach, and we use also advanced test stands to test as much as possible in-house. And then another important point is that there was a design for manufacturing. It means that, of course, you know, we are mainly the engineers and we like to do fancy things, but it is important to have each time somebody from production who will cool down you and say, no, that's nice, it's great, but it is difficult to produce. And of course, due to this, you have each time a meeting with the double time, but that's another point. If I will go here is the structure. Again, I'm a little bit running out of time, so it's important to say that it was really from engineering point of view, we are the team of application, system engineers, design, FEM engineers, production. There is also test engineers, quality inputs, quality engineers. In principle, it is a cooperation of three parties. It is the engineering in Siginolfi, in Onantola, in Slovakia, and then there is a big support from Smart Fluid Power from here, from university, as a standalone company, actually, to be correct. What we have interesting is also our advanced dynamic test stands, because, again, to be in demolition market is not easy, because to do testing on site, it is very difficult to find the same conditions. When you are doing the tests, you need to keep the conditions to make the repeatability, to be precise, and so on. But when you are in the field, in demolition, there is no, I would say, there is no hour, 1 hour of the working, which is the same like 1 hour before. So due to this, we invest, I would say, a lot of time, money, and everything to build the advanced test systems where we can easily simulate the loading conditions for smart cylinders. And this is very important. We spend a lot of time on the performance measurements on our prototypes, but also on the lifetime, where, for example, we tested 1,000 hours for ODA standard. Here is, for example, a very nice example how we improve this CA technology. It means this cartridge amplifier, the origin, where we started, has some flow 16 liters, which is some performance, which is showing you how your booster is crushing your resistance, how it's crushing fastly. And here you can see at the same conditions, the smartCylinder 2.0, which is adding 118% in speed. So really, I would say this was big improvement in terms of from smartCylinder 1 to smartCylinder 2. Here is another example. Not each time we are able to have enough power or something like this, so we have to build an additional frame. Then, of course, you have the problem with the power because some excavators are really big. So we take it easily and we take the excavator, connect to the frame. I call it a little bit like a field test in the factory because really to do the field test is difficult. You need to involve a lot of parties and so on and so on. And but in this way, it is easy way. You take the excavator and you are testing the technology on application, but you can control the load, you can repeat the load. This is also, I would say, the unique approach in this case. Another important are another boosting stand or booster production test stand, which was also produced or which was developed only for the testing of cartridge amplifier, cartridge boosters, and ODA system. It means that everything what is produced now or what was developed, we can test after the production. It can be used also for service. We are setting some valves. It's a high precision, online test evaluation, connection to the cloud data. So all this, everything, all these new things is there. Another tool which we used in the development was the FEM and CFD simulations. So the FEM and CFD, I would say that's the standard for the big companies, and this digital twin approach, big companies are speaking about it. But I would say in medium company like we are, it is not standard to use these twins and to use the simulation. But really, it is helping, and I would say that this project is also the confirmation that this digital twin approach, where you are doing all simulations, CFD and all these things, FEMS, system simulation, is also suitable for small companies, and it is helping. Of course, you need to find the right partners and so on, but on the other hand, it's really benefit and it is a speed to market and really for also medium size and also small companies. Here is another big support from Smart Fluid company, because it is a 0D simulation. I would say on level of components and also on level of system, where we are using the software and expertise to simulate and to predict the behavior of the system before the production, also in case of some troubleshooting. Another point is also what it means that we are really using these tools daily. It means that also when we want to make some design change, it doesn't mean that we sit down and say, okay, we will remove this part or we will shorten this. No, it's not working in this way. When it is needed, we make the simulation. We make the system simulation. So no design change without the simulation. This is the rule which I can say is really useful and many times confirmed that is helping. And finally, of course, all these simulations are giving us also some efficiency point of view. it is important to simulate because not each time you can measure everything. It is very difficult to measure. In some condition, it is dangerous to measure on the test rig, or you don't have enough power, or you don't have the right sensor. But we take some measurement points, and these measurement points are used for calibration of the system simulations, and then we take from the system models, we take the efficiency maps, and in this case, it was integrated to Excel for easy, the Excel is only at the front, for easy, I would say, system sizing.